we are going to do the leaching of alumina from the bauxite ore, because the ore for the alumina is bauxite ore. We need to write the balanced chemical equation for the preparation of nitric acid by Ostwald processes. Unpaired electrons will be there in the d orbital. Due to this strong linkage, the pairing will be taking place themselves. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we have discussed about the model paper of Part A and Part B. Today, we will go through with the Part C, how the question will come from the inorganic chemistry. Let us discuss now. In a Part C, again there will be a 10 question. You need to attend only 5 questions. Each question will carry 3 marks and you are going to get 15 marks from the Part C. And all these questions will come from the inorganic chemistry parts. Okay, let's see the question now. Write the chemical equation involved in leaching of pure alumina from the bauxite ore. So here you need to write the chemical reactions which has been involved in leaching of alumina. So already we have understood that what is a leaching process. Leaching process is a process where the ore which has been treated with a suitable reagent to get a precipitate, right? So here we are going to do the leaching of alumina from the bauxite ore, because the ore for the alumina is bauxite ore. So we are taking the bauxite ore here and we are going to treat with the very strong bases and later it has been leached. Okay, so here we are taking the aluminium oxide, which is a ore of alumina, okay, which is a bauxite ore which has been treated with suitable reagent. So which reagent we are using here? NaOH, and in presence of water molecule, it gives rise to the sodium aluminate will be formed. What does it form? It forms sodium aluminate. In the next step, the solution is later neutralized by passing the carbon dioxide gas. So this is the sodium aluminate. To this, we are going to pass the carbon dioxide and it forms aluminium hydrate, which is also known as what? Hydrated aluminium with a formation of sodium bicarbonate. In the third step, the hydrated aluminium which is filtered and dried to give a pure aluminium. Pure alumina will be obtained and water will be removed. This is how the leaching process will be done by taking the ore of aluminium or alumina, that is a bauxite ore, which has been treated with suitable reagent known as sodium hydroxide to get a alumina. To get what? Alumina. This process which is known as the leaching of alumina from the bauxite ore. Remember, in chemistry, if you write the balanced chemical equation, you will get a marks. If you don't balance the equation either in the left hand side or either in the right hand side, you will lose the marks. And especially in chemistry, if you don't balance the equation, which is always equal to the not writing any equation at all. So always be careful while balancing the equation. And if you don't know that how to balance it, write it in a pencil first. Later on, you can write it with the pen. Okay. So 3-step reaction you have to write. Suppose if you write first and second one, you will get only 2 marks. Or if you write all the 3 steps where the bauxite ore which has been leached, okay, you will get a 3 marks. For writing all the proper balanced equation, you will get a 1 mark. Totally it carries 3 marks. Next we have, with the reaction condition, write the balanced chemical equation for the preparation of nitric acid by Ostwald process. This is a question from the P block element. So here again you need to write the reaction processes. How does it involves in preparation of nitric acid by Ostwald processes. Especially in the P block element, there are three main questions will be there. One is preparation of ammonia by Haber's process, and another one is preparation of sulfuric acid by contact process, and we have one more method, that is preparations of nitric acid by Ostwald process. Any one of the questions will be given to you in this part. Okay. So here we need to write the balanced chemical equation for the preparation of nitric acid by Ostwald processes. Let's see how to write it first. So ammonia is oxidized in air in presence of platinum rhodium gauze as a catalyst at 500 Kelvin, and it gives rise to the nitric oxide. This is the first step. So what is the first step? You are taking ammonia, which is allowed to react with oxygen in presence of platinum or rhodium as a catalyst at 500 Kelvin. It gives rise to what? Nitric oxide will be formed with the formation of water molecule. If you write this reaction, you will get a 1 mark. Again, after that, this nitric oxide, which has been oxidized by air to form a nitrogen dioxide. Again, you are taking the nitric oxide, which is allowed to react with oxygen to form a nitrogen dioxide. If you write this reaction also, the second step, you will get a, these are the steps, okay. You will get a 1 mark. And in the third step, you can see that nitrogen dioxide, which is formed, later it will be dissolved in water to form a nitric acid. So this nitrogen dioxide, if you dissolve it in a water, you will get a nitric acid, and again this nitrogen or nitric oxide, which has been recycled back. This is how you can easily write the 3-step for the preparation of nitric acid by Ostwald processes. What you will write in the first step? In the first step, just write ammonia is going to react with the oxygen by using platinum and rhodium as a catalyst to form a nitric oxide with the formation of water molecule. In the second step, where nitric oxide is again going to react with the oxygen to form a nitrogen dioxide. In third step, nitrogen dioxide when it is dissolved in water, it will give rise to the nitric acid with the formation of nitric oxide. This nitric oxide again it will be recycled back. So here also again you need to worry about the balancing of chemical equation, because it is very important to balance the equation on left hand side as well as on the right hand side. For writing all the 3 steps, you will get a 3 marks. Next question will be goes like this. How is ozonide oxygen is prepared in the laboratory? Write the chemical equation. And second question is complete the following. So here we have a 2 question. The first question will carry 2 mark and second question will carry 1 mark. Even though it is 3 mark, there is no 3 mark question at all directly from the P block. Okay. So let's see how to write the preparation of ozonide oxygen. So ozone is prepared by passing the silent electrical current through the oxygen. So here you are taking the oxygen, which is allowed to prepared by using silent electrical current. Electrical current. What does this silent electrical current indicates? Silent means it is a sparkless electrical current we will be using here to prepare the oxygen, to prepare ozone from the oxygen. I'll repeat once again. Here we are preparing the ozone from the oxygen by using the sparkless electrical current, which is also known as silent electrical current. So if you write this explanation with the proper balanced equation, you will get a 2 mark. And again we have one more question. Complete the following, where calcium oxide If it is react with the water, we know that it will form a calcium hydroxide. If you write this product, you will get a 1 mark. Easily you can get this 3 marks in the P block element. Next we have one more question from the P block, which is the strongest acid among the hydrogen halides. Give a example or give one reason and write the structure of hypochlorous acid. Hypochlorous acid. Again, for the first question it will carry 2 marks. For the second one it will carry 1 mark. Okay. Which is the strongest acid among the hydrogen halide? If you write the hydrogen halides, that is HCl, HF and HI. These are the hydrogen halides, right? So among this, which one hydrogen halide is more strongest? Here, the hydrogen iodide is the strongest hydrogen halide because the low bond dissociation energy or low bond dissociation enthalpy of hydrogen iodide. So just write all the 3 hydrogen halide, then you will understand this hydrogen iodide is the one where it has low bond dissociation enthalpy. So if you write this, by identifying the strongest acid, you will get a 1 mark, and for writing the reason, you will get a 1 mark, and totally it carries 2 marks. Okay. We have one more question. We have to draw a structure of hypochlorous acid, which is the oxo acids of chlorine. Oxo acids of what? Chlorine. Okay. How to write this structure? See, we have oxygen. Between oxygen, we have hydrogen and chlorine, and this is how you will write the structure of hypochlorous acid, or you can write this structure also like this. Okay. Any one structure you can write. Coming into the next question, what are interstitial compound? Write any 2 characteristics of interstitial compound. Here, for defining the interstitial compound, you will get a 1 mark, and writing the 2 important characteristics, you will get another 2 mark. Okay. So, how to define the interstitial compound? We know that when smaller atoms like carbon, hydrogen or nitrogen were trapped inside the crystal lattice. So, this is known as interstitial compounds. What is interstitial compound? In a metal crystal lattice, if you see that some of the smaller atoms like hydrogen, carbon and nitrogen will be get trapped inside in the interstitial compound of that transition metal. That is known as interstitial compound. Why it is known as interstitial compound? Because these are the vacant spaces which is found in the metal. This vacant spaces we call it as a interstitial site or a vacant site. When it is occupied by some of the smaller atom like carbon, hydrogen or nitrogen, we say it is interstitial compound. Example is titanium. In the titanium metal, the carbon is a one which is going to sit in the interstitial site. Similarly, in the manganese, the carbon is a smaller atom where it goes and occupies that interstitial site. Coming into the characteristics, they have higher melting point and higher than those of the pure metal, and they are very hard and they are chemically inert. Any 2 characteristics you can write. They are chemically inert, it has very high melting point, and also you can say that it is very hard. Coming into the next question, write the balanced equation in the manufacturing of potassium dichromate from the chromate ore. Here also, hope you know that this is one of the important, most repeated question. Most repeated question Hope you know that in your quarterly or in the midterm or in your unit test, we have discussed with this a most important question, that is manufacturing of potassium dichromate from the chromite ore. Here also, if you write only the balanced chemical equation, the 3-step reaction, you'll get a 3 marks. How to write? I'll show it once again. So, the chromate ore is mixed with soda ash and later it will be burnt with air to form a sodium carbonate. To form what? Sodium carbonate. Here we are taking the chromate ore which is allowed to react with the soda ash, which is nothing but a sodium carbonate. In presence of oxygen, it forms a sodium chromate, which is a yellow mass. Okay, which is a yellow mass with the formation of iron oxide along with the formation of carbon dioxide. This is the first step. In the second step, this yellow mass which will be washed with water and later it will be treated with a suitable acid to form a sodium dichromate. To form what? Sodium dichromate, which is a orange in color, which is a orange in color. Next, this sodium dichromate which has been treated with potassium chloride to give potassium dichromate. Again, you are taking that orange color sodium dichromate which is allowed to react with potassium chloride. Potassium replaces the sodium and forms a potassium dichromate along with the formation of sodium chloride. This potassium dichromate which is also orange in color. So, hope you are understood with this 3 important steps which has been involved in manufacturing of potassium dichromate from the chromate ore. Just if you don't know that how to explain, if you write the balanced chemical equation here, you will get a 3 marks and all the 3-step reaction you have to write. Okay. Next question will be, goes like this. What is lanthanide contraction? Mention any 2 consequences of it. This is a question from the D and F block element. Here, you need to say that what is a lanthanide contraction first. So, for defining the lanthanide contraction, you will get a 1 mark and writing the 2 correct consequences, you will get a 2 mark. Because this is a question for the 3 marks, you need to write it properly. So, what is a lanthanide contraction? We already know that it is nothing but a decreasing in atomic radii from lanthanum to lutetium. As we move left to right in the periodic table, we all know that atomic radii which is gone decreases. This is known as lanthanide contraction because it belonging to the F block, where from lanthanum to lutetium, this atomic radii is gone decreases. Hence, it is known as what? Lanthanide contraction. And coming to the consequences, we all know that the consequences tell that the almost all have a identical radii between zirconium and hafnium, and also the members of or radii of the members of 3D transition series are similar to the 2D transition series. So, any 2 proper consequences if you write, you will get a 2 marks, and writing the proper statement, you will get a 1 mark. Okay, this question will carry the 3 marks. Hope you all understood with this question. Coming into the next question, using the valence bond theory, explain the hybridization, geometry and magnetic property of tetracyanidonickellate 2+ ion, and where the atomic number of the nickel is given, which is nothing but a 28. Here, you need to say what is a hybridization, what is a geometry and what is their magnetic property. So, before that, first write a complex which is given on your question and say that what is the oxidation number of the central metal atom. Here the central metal atom is nickel and it has +2 oxidation state. Coming to their electronic configuration, it is given as 28. Just write the electronic configuration, argon 3d8 4s2. So, in the d orbital, it has 8 electrons, whereas in the 4s, it does not contain any electron at all. Just I am writing the electronic configuration. It is argon 3d8, 4s and 4p. All these 4s and 4p are empty because it do not contain any electron. And you can see that in a 3D we have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electron we have. We know that the central metal atoms are surrounded by 4 cyanido ligand, right? So cyanido is a strong ligand, hence the pairing of electrons which is taking place. Here you can see that there are 2 unpaired electrons will be there in the d orbital. Due to this strong ligand, the pairing will be taking place themselves. As a result of this, the hybridizations will be takes place and give rise to the 4 vacant dsp2 hybridized orbital. You can see here, when the electrons are paired up, there are 4 vacant space will be required by the 4 cyanido ligand and lead into the formation of dsp2 hybridization. This is a D and this is a 3D and this is a 4s and 4p. Since it is taking the 2 p orbital and 1 s orbital and all the d orbital, it is dsp2 hybridization. Okay, and the 4 pairs of electron from the cyanido ligand which goes and occupies at that position and give rise to this dsp2 hybridization. Okay, after that you need to say that if any unpaired electrons are there, you need to say their magnetic behavior. You can see that here no unpaired electrons will be there. So, due to the absence of unpaired electron in the complex, it is diamagnetic in nature. And if you see that, there are 4 cyanido ligands are going to attack the nickel, which is a central metal atom. It has square planar geometry. It has what? Square planar geometry. Okay. Hope you all understood that. In the first step, you need to write the oxidation state and electronic configuration of the nickel. After that, you need to show that how many electrons are unpaired in the nickel in the ground state. Due to the strong ligand, when they paired up, it gives us to the 4 vacant spaces that has been attacked by 4 other cyanido ligand to form dsp2 hybridization and say the magnetic behavior and also with the geometry. Okay, if you write proper this, you will get a 3 marks. Next, we have write the geometrical isomeric structure of tetraamino dichlorido cobalt plus ion. What is the oxidation number of cobalt in this complex? First of all, for writing the first question, you will get a 2 marks, and writing the second one, you will get a 1 mark. So, how to write the geometrical isomers of the tetraamino dichlorido cobalt plus ion? Here we know that cobalt is a central metal atom and it has been attacked by 4 different amine ligand and also by 2 counter ion, right? So, here you can see that cobalt is a central metal atom and which is occupied at by 4 different amino ligand, which is a amine ligand, okay? But we have counter ions also, that is 2 chlorine, which is also there. So, if I say it is geometrical isomerism, you have to say the cis and trans form, right? So, in the cis form, we have understood that if the 2 ligands are present at 2 functional groups are present at one side, we say it is cis form. If it is present at the opposite end, we say it is trans form. Here I have written the Cl which is present in the same side, hence it is a cis form. Similarly, in the trans form, the 2 chloride group which is present at the opposite end and forms a trans form. Like this, if any one of the compound will be given to you, identify the central metal atom surrounded by how many ligand and counter atom and just write the charges which is also there. Okay, so this is very important and one of the easiest question where you are going to just write the cis and trans form. Okay, and we have one more question where you need to write the coordination number of the central metal atom, that is cobalt. So, the oxidation number of the central metal atom is 6. Okay, just write 6. If you attend this to, you'll get a 3 marks. Coming into the next question, which is the last question in the 3 marks. Okay, give any two postulates of Werner theory of coordination compound and write the formula of potassium hexacidoferrate 3. Here, for the first question, you need to write the proper 2 postulates of Werner theory. You will get a 2 marks. And for the second one, you need to write the formula. So that you will get a 1 mark. So we are familiar with the Werner theory. Werner theory says that central metal atom shows the 2 types of valency, the primary valency and secondary valency. And we have understood that primary valency is always ionizable and it is always satisfied by negative ion, whereas the secondary valency are non-ionizable and it is always satisfied by ligands as well as with a negatively charged ion. If you write these 2 points, any 2 points if you write, you'll get a 2 mark. Why I have put the 3 postulates here? Because sometimes the question paper setter, they can ask you the Werner theory for the 3 marks directly. Instead of asking for 2 marks, they can also ask for the 3 marks. So you should know with all the 3 postulates. Because it is a 3 mark question, you must have the knowledge of writing all the 3 points. Okay. And we have one more question, that is potassium hexacidoferrate 3. Potassium hexacyanide in the sense the central metal atom is a potassium surrounded by 6 cyanido ligand. How to write this? See, and we have ferrate 3 plus, which is a counter ion. So here potassium hexacyanide ferrate 3. Okay, this is how we have to attend the 3 mark questions in your second PUC chemistry. So hope you understood, and it is very easy to score 15 marks in the part C because all these questions which comes from your inorganic chemistry, have a look on it because all these questions are very easy to attend it, and only thing is you need to recall and you have to practice with the chemical reaction. If you don't have a much practice in writing the reaction in the examination also, somewhere if you miss, even though you will say that we have written the reaction, though examiner will not give the marks, okay, or evaluator will not give the marks. That is why I am suggesting to you all to practice with the chemical reaction, write 5 times or 10 times, however it is flexible for you, and practice with the most important questions in the inorganic chemistry. Hope you all understood with this. So in the next session, I am going to discuss with only the part D, which carries 5 marks. Till that, stay tuned. We'll come back. Till that, take care and be safe. Thank you.